Good evening once again, and welcome back to the Special Developers. Today will be our last day or our last session for the first phase, and we will be wrapping up with the Google Earth Engine. Yeah, so basically today we are going to run a classification using one of the ML algorithms as the random forest algorithm in Earth Engine to do the classification. I've shared a shapefile in the group, and we will be using that. That will be our AOI. That will be our AOI. So to start, let me launch my QGIS, and let's check the data set that we'll be using for our classification. And in our repo, there is this. Let me just go into our repo. So when you enter into the repo and you go to data set and you go to module 4, you are going to see this AOI tree, right? When you go in there, there is this training data set there. I think the one I pushed online had a space in there, but you can just close the space in between the training data. Okay, yeah, to be like this. But I can also share. I will share this data on the page so that you can have access to it. Say maybe I'm going to the repository. Will be a long. Okay, let me get it into the page. Okay, so I've shared another data set on the page, and that will be our training data set. So let me just drag it onto the QGIS. And the data that I shared on the page earlier, the geospatial AOI, you can also load that in your QGIS, just like what I've done. So basically, these are the data sets that we are going to use for our classification. And with the training data, you can create your own training data. So assuming you are going to run a classification over an area, you have a high resolution image or any like the image that you want to classification, or people can even go on the grounds to pick sample data, okay, for you to use for the classification. Well, we have this data set here, which is a bit old. These data sets were picked on the ground some years ago, I think 2015, 2016, thereabouts. Yeah, to classify this area that we see here. Let me go to the attributes table. Okay, so it's 2016. Yeah, so we are having these columns. So you can see we have the X and Y, we have the land cover, we have the classes. Just forget about this area. This layer or column was used to differentiate the points when the points were picked. Okay. Yeah, but that's not we wouldn't need this particular column. All that we are interested in is class and the land cover. So usually when you pick the point or you pick the coordinates, we usually state the class. So let's say if this is built, so as you are picking your training data, you give it a class. And because the computer wouldn't understand this, we reclassify, or we regrouped it. We have to reclassify them under using the numeric or using numbers. So you can see, as you see here, we have built whenever you see any class with 1, it's built. When you go down, when you see 7, it's water. Okay. So when you see 4, it's forest, and so forth. So this layer or this column is what we'll be using for our classification. But this is just here for us to know what 1 actually means, what the classes actually means. Okay. All right. So let me just close it. So in actual sense, you only need the land cover column for your classification. That's what the column that we'll be using or be pointing the algorithm to. And we also have our AOI here, and this AOI is our area of interest. Yeah. So that's what we'll be using for the classification. So let's go back to our Earth Engine. That is our main agenda for today. So to do that, let's go to assets. Okay. We are coming to upload our data set into our assets. So assuming if you have it, if you have the data in your assets already, that is fine. But we are going to just apply what we learned last is it Monday. What we learned on Monday, we learned how to upload our shapefiles or our vector data or TIFF data set into our assets. So that's what we are going to do. So let's quickly do that. So I'll come to new and I'll select shapefiles. Then over here, I'll go to select. Then I'll navigate to where my data is. So I'm navigating to the AOI section. That's where I have my shapefiles. So I'll just select everything. These extensions meet the criteria. So it's telling me that I have a similar data in my assets with the same name. So I'm going to give this another name. So I'll give this geospatial training. Geospatial training data. Okay, so I'll just give it that name. Then I'll just click on upload. So when it's done, we are going to see this symbol here. So it's uploading. Okay, so it has started uploading. So let's add our AOI to it. That is our geospatial AOI I shared on the page. So I'll go to in the repository online. When I push this, you are going to see that under data sets module 4, and you see geospatial AOI. Yeah, so you can see, well, this time this QMD is not this DAR extension is not needed when we are uploading to Earth Engine. It doesn't meet the criteria here. Okay, so I'll also give this a name, geospatial underscore AOI. Okay, then I'll click on upload and it's upload. Okay, the first one is done. So this is also about to start uploading. Okay, so let me just pause for a second for those of us who are trying to get their data set uploaded to do so. Okay, so let's continue. By now, we should all get our data uploading. So the next thing is to get our image. Okay, so for the purpose of this demonstration, we are going to use Sentinel-2 for our classification. We are just going to do a basic classification using the random forest algorithm. Okay, so I'll search for a data, a Sentinel-2. I usually use, I think, yeah, the multispectral instrument level 2. You can choose to use any of these images that will suit the kind of analysis that you'll be using. So I'll just click on it. All right. And as I mentioned in my previous sessions, I made mention that each time you are going to, when you're new to that image, try as much as possible to read the description and know the band combinations and the image properties. That will help you a lot in your analysis. All right. And this is the image ID. That's the Copernicus Copernicus /S2_SR. All right. So because of time, I don't want us to write a lot of codes today. So let's use the example. I'll just click on C example for it to write the basic code for us. So that I will just edit this code and move on. All right. So when you click on the C example, this is what you are going to see. It will open another tab for you, right, with this codes written in it. So I'm going to explain these codes for you to understand. You know, when I started with this G, I made mention of, if you remember, I mentioned functions. So this is a typical function, the mask to clouds. So this is a function that they've written to mask out cloud, okay, to mask out cloud using these formulas. So if there is any pixel that is not meeting the formulas here, it will just mask those clouds out of the images. All right, and I hope so. This is understandable. Okay, so let's move on to the next set of code. We are all used to this. When we are trying to load our image, that's our Sentinel-2 multispectral image, and we are saying that over here the default date that they place there is 2022 1st January to 2020 1st January to 2020 30th January. But I want to run a classification over a year, so I'll just change this to 12 to get a 1 year composite of our AOI. Okay, and the cloud pixel, and I explained where you will see this parameter, this value. This is in the metadata of the image. Let's go to the image so that I show you where that is. So let's something. Okay, so yeah, so that's it. So you come to the image properties. So what the filter that we are using for the the image property that we are using for the filtering is coming from this side under the image property. You remember in my previous session, I was saying you can filter the image using any of these properties. Okay, so over here we are filtering using the cloud pixel percentage, which is the granular specific cloudy pixel percentage taken from the original metadata. Okay, so over here they are saying that they should filter all the pixels or the cloudy pixels that are less than 20%. But I want to reduce the percentage. 20% is too much for me. I want to reduce the percentage to for the scripts to filter the images with lesser clouds. Okay, at least we should get a cleaner cloud. And over here, I made mention of this map. And during the introduction, I made mention that in Earth Engine, when you see map and the map is with capital M, we are talking about this interface, the UI, the map section here. But when the map is a small letter, as I explained, so map is performing the functions of a loop, a for loop. Okay, so the map here is trying to tell the system that the image collection, all the image collections here, the image collection here contains images. Okay, so I want you to apply this function, the function we have here, apply that function to the image, the image collection, so that it will mask out all the clouds from the image. So it's like we passing the image collection through that function. Okay, so you can see that the function itself is accepting an image. So this mask will just go through all the images in that collection and mask out the cloud. Okay, let's move on. And as we all know, this is the visualization parameters for visualizing the image. So over here, they wanted to visualize the RGB component. That's the 432. That's RGB. Okay, and these the min and max are usually used to stretch the image to get a nicer output for visualization purpose. You can play with these figures to get like a nicer visualization. All right, and the map.center is centering to these coordinates at this zoom level. Okay, but for the purpose of our illustration, I don't want us to use the map.center. We want to center it to our AOI. Okay, so at this point, we are going to bring in our AOI, our area of interest. So let's come to our assets. Then let's scroll down and search for the name that we used in let me refresh this to see if I'll see the name. I labeled it as Geospatial AOI. That's it. So I'll just click on it and I'll import it into my script. So that's our Geospatial AOI. So I'll just import it into my script and I'll label it as AOI. That's our area of interest. Okay, I hope we are good. All right, so let's continue. So at this point, I want us to filter the images that falls within within our AOI. Okay, so I'm going to add another filter to our image collection. So I'm saying that we don't want you to collect all the images for the world. We need just the data around our AOI, the images that falls within our AOI. So I'll say I'll use this function filter filter bounds. Okay, filter bounds. If you want to know what filter bounds is, as I showed you the other time, you come to the document, then the docs, the documentation, then you check this time around we are applying the filter bounds to an image collection. So you scroll down and you check for an image collection and see how the filter bounds is used. So it's trying to tell you that the filter bounds is only takes a geometry. Okay, so in this case, our geometry is what our AOI. So I only pass our AOI to it. Okay, and that's it. And this time I want us to also center the map to when the map loads, you should center the map to our AOI. So I will say map dot center object. Okay. Sorry. Center object. Then I'll say AOI. So this time when I run the application, when I run the script, it's going to zoom in to our AOI instead of United States of America. So I'll just run to see if everything is on point. Okay, so it has zoomed to our AOI, and that is the image. So you can see now the data, the image is not covering the whole world. We only have the image that is covering, or that falls within our AOI. Let's add our AOI to the map so that at least we can see the extent of our AOI. So over here, I'll say map dot add layer. Then I will say AOI, add AOI. We won't give it any visualization. We wouldn't color it or give it any color. We'll just use the default color to see where it's falling. So I'll just, oh, sorry. Okay. All right. So let's run that. Okay. All right. So that's our AOI. This is where it's falling. Okay. So at this point, we only need the image that is falling within our AOI. So we are going to clip our AOI out of the image here. So to do that, I'm going to, okay, let me do that here. Over here, they used mean, but I like using the median. So I'll declare a variable here called composite. Okay. Then I'll bring this data set dot me. I'll just take this one out. Let me just copy that and just move this. Then over here, I will say data sets, okay, dot median. Oh. Okay, then I'll bring the composite here. So now what I've done here is that the data set we see here is the image collection we have here. So over here, I'm trying to get a mosaic or a composite of that image collection using the median. Okay. Then so now after getting the composite, I've assigned it to a variable called composite. And now I'm getting the, I want to see the composite on the map. So I've added the composite, and the visualization parameter will still be the same as what we have here. So let me just run this and let's see. This time around, you see, oh, okay, I forgot to do one thing. Yeah, we are still going to see the whole image. So let me just clip the image. So to clip an image to your AOI is as simple as this clip. So the image, and so dot clip, then you bring your AOI. Okay, so this time around it should clip the image to our AOI. Okay, so you can see that. Let me uncheck our layer. So that's our AOI. The image clipped to our AOI. All right. Let me just pause. We are moving to the next stage. I'll just pause for another second or two, and I'll continue whilst we try to get to this stage. Let me just. Okay, so let's move on. I hope by now we've been able to get to the stage. So at this point, we would have to get our training data set, or we want to train our data set. Okay, so to train the data sets, so we have to the next set of codes that I'm going to write is going to take the pixels of where Okay, before I do that, let me add our training data sets to the map. Okay, so that I'll use that to explain what I'm about to do. Okay, we've not imported our training data, so let's do that. Sorry. So I'll just come here to spatial training data and I will import it. Okay. All right. What is it? Okay, I didn't allow it to load before I imported, but it's okay. It's fine. It's going to work. I'll say training. Let me use small. Okay. Then I'll just copy this variable name and come and add it to the map. Let me just put off this. So you can see our training data scattered on it. Okay, so these are our training data. So now what we are going to do now is that we are going to get the pixels in which this training data set falls. Okay, so let me just zoom to this training data. I want to zoom to this particular one. So over here, this training data we see here, this point we see here, is falling on a certain pixel here. Okay, so what we are trying to do here, then the next line of code is to like that we are in the script, we are overlaying the points on the image, then we'll clip out or take those pixels for our training. Okay, so that's what we are going to do. So to do that, we will declare a variable called training. Okay, so let's declare a variable. So our variable will be training. Okay, then we are going to use our composites. So say composites. All right, then we will use the function sample regions. Okay, it's correct. Then I'll just open the brackets and pass in our parameters. So our collection, so the sample region takes the collection. So say collection, our collection will be our training data. Okay, so let me just get this here. So that's our training data. Okay, then the training data, we want to assign the classes. Okay, so when it picks the pixel, it will just assign the class to it. So we'll use the property within the training data. So let's use property, and the property we are going to call that column. Do you remember the column for, let me see if I still have the QGIS opened. All right, so over here we've called the training data and we want to call this column, the column layer land cover. So maybe if you also have your classes, you have your own training data and you have your classes under another name here, maybe LULC. So you are going to call that particular column by name, by the column name. Okay, that's what we want to do now. So we are saying that land cover, that's the column name. Then we'll give it a scale, the scale for the image. Or set them. Okay, so over here, let me just comment. It's good to comment your code. Okay, so let me comment for the purpose of those of us who will be viewing the script after this session. So I'll say overlay the points on the image to get your training data. All right. Okay. Yeah, there's an error here. So each of them should be separated by a comma. So when you're moving to the next line, you bring a comma. All right. So now we have our training data. Now let's move on to our classifier. Okay. So the first thing we need to do to classify an image is to get our training data. Okay. All right. So to get our training data, and that's what we've done. So at this point, I'm going to pause again to wait for all of us to get to this stage before we move to the next step. Okay, can we continue? Okay, so let's move on. So at this stage, what we are going to do is to get our classifier. So this is a basic classification that we are about to do. Okay, and under normal circumstance, we are supposed to get your what do you call it? Oh, you are supposed to get, if you have a training sample, you'll be doing 70-30, 70 for the training and 30 for the testing. But because of this illustration, I'll use all the data sets are not enough, so I'll use all for our training. Later, I will share another video after the session in the page, showing you how to do those separating the 30% from the 70. Okay, the 30% training and the 70% training and the 30% testing. So we'll get to that bit. Okay, so let's move on. So we'll train our classifier. Okay, we'll train our classifier. So let me just say train classifier. Okay. So I'm going to declare a variable called classifier. Okay. Then I will say EE. So EE, if you want to call the classifier, so EE, then you will say classifier. Then we will be using, there are a lot of classifiers, but what we want to use today is the simple random forest. Sorry, the small, is it small? Let me check the name. Yeah, I think it's small random forest. Let me get that here. Is this smile or simple? Smile. Okay, so yeah, so it's smile random forest. All right. Okay, so you can see it takes the number of trees, the variable per split, then the mean leaves. Yeah, so we'll be doing that. So the name is smile random forest. Okay. Then over here, we are going to state the number of classes. So I think in that data set, there are 7 classes. So I'll use 7. Okay, so we are going to, it is going to use 7 trees to do the classifications. Then I will say train. Then I will open a bracket and bring the curly brackets to enter the other parameters that will be passing through that function. So I will say the features I hope I don't get an error. The features are usually our training sample. So the training that the images that we've picked out using our training sample. Okay, so we'll just get our training and place it here. Then we will now use the class, the column that we are using for the classification. So we use the class property, say class property, and the class property will be is the same as the property we used here. So let me just copy this and paste that here. Okay, and the input property will just get all the bands, the bands in the image. So we'll say inputs properties. We are saying we need the bands in the composites. So we'll say band, there is a function called band. Is it band names? Yeah, I think it's band names. Yeah. Sorry. So one thing that you also have to take notice of is when you are coding in F Engine and you want to call a certain function, inbuilt function in F Engine, when you are typing and it's correct, you will see that the color will change to this color. But if you are wrong, you will see that it still has the other text, black. So that's one thing you can also take notice of. All right. So here, our classifier over here, we've used all our training data for the classification. Okay. So now we want to apply our classifier on the image. Okay. That's what we want to do now. So now we've trained the classifier. We want to now classify our image. And to do that, let me bring. So to do that, so here we classify our image, our composites. Let me use composites. So here we are going to classify our composites. That's our image composite. Okay. Then to do that is as simple as we declaring a variable. So let's declare a variable. Okay, and this variable will be called, you can name it either classified or classified image or class underscore image, any name at all, just for you to know that this variable is holding the classified image. So I'll say classified underscore image. Okay, then I'll say the composite. That's our image composite. Okay, image composite. Then we'll apply the classifier on it. So this is a classifier that we've trained. Now we have to apply it on our image to get our classification done. Okay, so to do that, I will say classify. There's a function called classify. Then I'll apply our classifier to it. This is our classifier. I'll apply it to our image. So at this point, this variable is holding our classified image. All right, so let me just pause for those of us typing to get to this point before I continue. Okay, so let's move on. So now that we have our classifier, we would like to check our classifier, or to visualize our classifier on the map. But to do that, I would like us to get our colors. Okay, so let's declare our variable for our palette, our color palette. You know, after your classification, we have 7 classes, so we have to make sure that our color palette will be 7 in color, in there's 7 in number, so that each of the classes will pick one color, and it will use it to that to apply to the map, so that we will be able to identify the pixels that are water, the pixels that are built, the pixels that are forest or vegetation. Okay, so that's what we want to do now. So I'm going to declare another variable called palette. So that's palette here. Then someone will ask, why are we using list? And if you remember your lessons in Python or in JavaScript, we made mention that list always keeps the order. Okay, so when you place an item at index 1, anytime you call it, that item will still be at index 1. It's not like the dictionary or an object where it usually reshuffles the order of the items in there. But with list, it keeps the order. So any item we define here, the first item will be the first class. And one other thing I forgot to mention is that when you are defining your classes in your training data, with a little experience that I've had with these data exports, try as much as possible to avoid using 0 for your class, labeling a class with 0. Or else when you extract your data and you try to get the extent of your data, the class that is 0 will match with the surroundings, and it will be difficult for you to get your data to that extent. So I usually start my labeling from 1. Okay, so my first class will be 1, then the second will follow up until the number of classes, the extent that I'll be going. So over here, the color palette, you are going to give it a palette. Let me just see if I'll get the right palette for you. You can just give it any palette. Okay, so let's give it any color for the purpose of demonstration. So I'm going to give the first color red. The first class red. I'm going to give the second color green. I'm going to give the third one blue. Let me not use blue. Let me use okay, let me just get the right color palette in like one of the color palettes in one of my codes, then I'll just share that on the page. Okay, but you can use any color palettes that you want to use in representing that class that you have. Let me just open another script here and just go into this. No, okay, let me just go into this. Um, let me just get this color palette so that we use this. Sorry, don't worry our head. So I'll just replace this palette here. So we are assuming that these color palettes matches with our classes. Okay. And let me just take these comments out so that I want us to take this comment out. Oh, sorry. So I'm going to share this on the page so that you all can get this. Oh, sorry. Okay, so this will represent index our class 1, class 2, class 3, class 4, up until 7. Okay, we also have 7 classes here, so it's the same. So let me just copy this and I'll paste it on the page so that we can use that in our script. There's no need for you to type. Oh, okay, there you go. All right. So now that we have our color palette, that is going to represent our classes that we've classified. We are now going to add our image or our classified image to the map. So to do that, I will just do map dot add layer. Okay, then I will open and add our classified image. This. Okay, then I'll pass my visualization parameter. This time, our min is going to be 1. That's the minimum class is 1, right? And our maximum class will be 7. Okay. Then we'll apply our palette. So we'll pass the palette. Oh, the spelling of palette is wrong. There is L. Yeah. I hope the spelling is right. Yeah, I think it's right. Yeah. Then we will now add this palette, our color palette here to it. Then after, I want to give it a layer name. So the layer name, I'll give it classified image. Okay. Oh. Classified image. All right, so I think everything is okay now. Yeah, so let's run our code and see if we are going to get our classified image. So I'll just put off the other layers, which we don't need them. So let's wait for our classified image to load. Okay, let me just bring, okay, so it's loading. My internet is a bit slow. Okay, so there you go. So this is our classified image. So you can see the image has been classified using the training data that we applied. So for our last assignment for this whole mentorship program, I would want each and every one of you to research and run the research on initially I made mention we'll be using the splits, the 70 for the training and the 30. I made mention I'll do I'll do a video after the whole mentorship program and post it on the page. But on a second thought, I want you to research and use that to split this training data set. What is it? Split this training data set into training and testing. So 70 for training and testing for training. 30 for training. So 70 for training and 30 for testing. So you rather use the 70% for the training. Then after you use the 30% for testing, then the next thing to do is to also run your confusion metrics and check the accuracy. That will be your assignment. And there are a lot of posts online that you could chance on, and you can do that. So during the assignments, if you have any challenge, let me know. Yeah, these days I'm a bit tight, so I struggle to come online, but try as much as possible to reach out to me during the weekends. Yeah, I can make time so that we go through it. If you have a challenge, yeah. But after, you can just save your data or your scripts in your script as a script manager and share that with me. Okay, so let's do it. So after you've written your code, after you've run and everything is okay. Okay, I want you to save. So just click on yes, then save it in your assets. But I created this here for this repo here for the program, the mentorship program. So I'll just save this here, classification, basic classification. Okay, so you can give yours any name that will help you identify your script anytime you come in there. All right, so that's my script here, basic classification underscore random forest. All right. So at this point, I'm going to open the floor for questions, and I'll be glad to answer. I have a function to also put this function. There's a function to put the classes, the legend here, and it's a lengthy one. Let me try and get that and also share with you so that you can paste it in your code, and so that anytime you classify, you can have your legend on your lower left. So let me go through my script again and see if I have that function there. Yeah, there you go. I have it here. So I'll just copy all this. Okay. There you go. Let me share that with you. Now, but let me apply it first. If it works, then I share that with you. All right. So from here, generating a legend. So we are assuming. So over here, as I made mention, here. So we have 7 classes here. So the first one represents the first class, the class the under the land cover. So if the first one represents the like class 1, second one class 2, class 3, like as I've indicated here. So when it comes to the legend generation, over here, this is there is a function that is going to create a UI panel here, and it was going to load your legend, the classes here. So these colors you see here should tally with the colors here. I think it's the same code I copied this color palette, so it's the same. Okay, so it should tally with the colors here. So over here, this is the Cyan is the first class. So if it's class 1, I'll just put a comment here. Maybe it's Agro Forestry Cocoa. If it's class 2, Belt. So that anytime anybody who reads the code will understand the codes that you've written. Then yeah, so with this line of code, the only thing that you need to do in this code is to just change here. Anytime you run your classification, just change the here. If you have 7 classes or you have 3 classes, make sure that here the labels are 3 and the color palettes are also 3. If it's 4, you make sure that your labels are 4 and the color palettes are also 4 in number. So the first will match to the first item here. The second will match the second item here. Then so let me just run and see if there's going to be an error so that we fix that. Okay, so this is what I'm talking about. So when you run your script, you are going to see this. Okay, so that anybody who sees your product will easily understand what you are trying to okay. So anybody who sees your map will understand what the products, the meaning of the product or the meaning of the color codes that you've used. All right. There's one last thing that I want to touch base on before I end the session. You can also publish your application. So in Earth Engine, you can publish your application so that you share with your colleagues as an app. Okay, so we are assuming this is our application. Okay, so to do that, you go to apps. Okay, I have a number of applications here, but maybe in your side you might have maybe if you are new to this side, you wouldn't see anything here. So you just click on new app. Okay, then give your app a name. So I'll just give it Geospatial. Let me use okay, so Geospatial classification. You can give it any name. Okay, sorry, classification. All right, then yeah. So it's going to generate this URL for you. So this is what people will be using to access your Earth Engine application. So when you are done, you have the owner, then the cloud projects. This is my ID. Then I'll just go to next. Then over here it's asking me where's your source code, and I'm saying is the current content of the editor. So the codes I have in my editor is what is supposed to use in compiling the application. If you have the code in your repository, you can select the repository, then you have to provide a path to that line of code. Okay, so I'll select my current content of the editor, then I'll click on next. So over here, it says feature this app in our public apps. So a lot of people they've published their apps to the public so that they can also use the application. So if you also want to join the open source community, you've designed a nice product, you want people to have access to it and also use it, you can check this. You can check this button on so that the moment you publish it, everybody who is in that community, in the Google community, or who goes to the public assets will see your app there. Okay. And over here, this is a thumbnail. So if you have a thumbnail for your application, maybe a logo or anything for that project, you can also click here and upload that thumbnail there. Let me see if I have a thumbnail on my desktop or downloads. Let me see. I don't have any image. Okay, let me take this as my thumbnail. So I'll select that and it's going to upload it. So anybody who sees the application is going to see this as my thumbnail. Okay. This is just a dummy thumbnail. It's a thumbnail I used for one of the videos. So when you are done, there are restrictions which you can restrict the app to a certain group. You can also provide a logo to the application. So if you have a logo, I'll use the same logo. Okay, so it's going to use the same picture that I use for the logo. Then when I'm done with all, then I'll just click on publish. So usually, this is our application. So usually it takes close to maximum 3 to 4 minutes to get the application done. So now it's compiling. So usually when you do this, it's compiling. When it's done, I think it will open in another tab for you to see the application. Let me check something out. Yeah, so when you click on it, you will see this. It's going to tell you that's not ready. Sorry, the spatial classification is not ready yet. So you can just keep it this way and you keep refreshing. Maybe in the next 3 to 4 minutes, it should be able that it should be completing by then. Then you can have access to the application. Okay, so it's done. So there you go. So you can see my logo here, then the application. Why is it not zooming to our AOI? What are we not doing right? I think during the compilation, something happened. Let's go back to our coach and see if we are not doing something right. Okay, so let me just run to see if there is an error in the coach. There's no error. So where from this? Because none of our data sets loaded. Okay. Let me go. Okay. And check that. Yeah, so basically, this is the process. Keep the existing. Basically, so this is the process of publishing an application. I can't see where the issue is coming from. Yeah, but under normal circumstance, it's supposed to load the data. I'm surprised it's not loading. Even the center. Okay, let me try something else here. Everything is right here. So I don't see any line with, yeah. So basically, this is how we usually publish an application. I will check the reason why the data wasn't loaded, but the app has been compiled and published, but it's not behaving as expected. So I'll check that and notify you in the group. So at this point, I'll just open up for questions. Then I'll bring the session to an end. And so today is going to be our last session for the phase one of the mentorship program. Yeah, so thank you very much for making time from August. Yeah, I think we started in August and we are in November, almost through in the middle of November. So we've done about 3 or 4 months. So let's say August, September, October. Yeah, so we've done almost like 3.5 months. Yeah, we thank you for your time and thank you for your dedication. And we hope that we've impacted. The main aim of this whole program was to impact the geospatial, um, to impact our knowledge that we've gained with our geospatial colleagues or friends in the geospatial communities, so that they can also apply or also train or teach people that didn't see this program. Yeah, and we are still going to keep the group, and God willing, next year in January, in the latter part of January, we will come back with the phase two of the program, and we are going to run a survey. Okay, a post survey, and would plead that each and every one of you would try as much as possible to complete the survey for us. So I'm going to paste the survey in the group so that we fill the survey for us. So that this is also the survey is going to help us plan for the next phase, okay, and to know what we did right, what we didn't do right, and what you're expecting in the next module or the next phase, and all that. And if like anything that you think will help the next phase, kindly let us know. So I've posted the link in the page, and I'll also post it on LinkedIn, our LinkedIn page, for those of us there to also evaluate us. All right. So thank you very much and stay blessed.